Welcome. In this particular lecture we're going to have a look at game input, some of the different mechanisms whereby we can collect and manage the input that we will be providing to our game. We'll start off first of all by giving you a bit of an overview of some of the different types of input that we can collect. We'll look here at some of the more traditional sources and also some of the ones that are a little bit more innovative. So there's a wide range of different types of devices, and you can see a collection of them appearing on the screen here, all the way from touch interfaces that we're using, for example, on our tablets, to our trusty keyboard and mouse, through to controllers, through to other visual devices like the Kinect. And by thinking about these different devices, you can see that they offer different types of usability profile, that they're suited to certain types of input. A lot of them use tactile touch-based input. Some, for example, the Kinect, though, is visual. It's based on motion and movement that it observes. And for some types of applications or some types of games, the controlling mechanisms can differ. Some are suited to certain types. And obviously we would want to make sure that whatever game we're developing, that we have available and maybe exploit the input so that it best maps onto that type of game device. For us, though, we are using a mobile device, a tablet-based or a phone-based device, so that simplifies things somewhat, but we do want to keep in mind that fundamental principle that we should be looking at how that device gets input from the user and then thinking, okay, how can we best then map that onto the type of game that we want to create. Just as a little aside to this, there are some innovative forms of input that are not really used at the minute for games, but it's not to say in the next 10, 15 years could actually become quite important. They include things like bioelectrical input, where the electrical signals that our body produces, we can measure those, and potentially they can be used as an input into the game. Arguably it gives a bit of an insight into the emotional or physiological emotional state of the individual. So that can give a way of tracking what they are feeling or how they actually are experiencing the game. Speech is another one. We routinely use speech by way of communicating with one another. It's one of our most common ways of, or mechanisms of communication. At the minute, speech recognition is actually fairly decent. It's got to a point where, for most accents, what is said can be transcribed with a reasonable degree of accuracy. Understanding what is said thereafter is also a more challenging process, particularly if it's semantically rich. But again, speech input into games is an area that hasn't been used much, but potentially of some interesting opportunities. And I suppose ultimately, being able to recognize our thoughts or our emotions more directly, again provide the type of sort of quite capable, powerful input into the game. Now, all of these things are slightly futuristic, but the technology is there, and maybe just as a matter of time. If you want, as a little bit of an aside, you can ponder how these types of inputs could potentially change games and the type of activity we could then get the user to participate within, or the control mechanisms that we could offer to the user when these types of inputs become available. Now, where we're concerned with the mundane or usual mobile devices and the types of input that they provide. So let's focus in on those devices in particular. For current mobile devices, they actually, obviously they provide a touch interface. But beyond that, they do have quite a broad range of sensors, and it's something that as the different generations have gone on, the range of sensors have increased, so that now they're actually quite rich. They can be broken up into a number of different types of sensor. First one is motion sensors, and they're ones that measure changes in the motion, the movement, the speed, the direction of travel, or whatever, of the device. So things that are like accelerometers, but how quickly the device is accelerating in a particular direction, or gravity sensors, to what extent gravity is pulling the device down, or gyroscopes in terms of how the device is currently oriented. So most of our phones or our tablets will be able to measure how that device is physically moved within whatever environment it finds itself within. You also have discrete environmental sensors themselves. So these are things that can measure, for example, the temperature of the air or the surroundings, can measure the pressure, like a barometer of the air, can measure the amount of light that is hitting the device, or maybe the amount of water vapor in the air itself. Some of these maybe are a little bit more difficult in terms of how they factor into a game, but they are the types of sensors that increasingly, certainly phones and other mobile devices are being able to draw upon. Finally, we also have position sensors, and these are related to motion sensors that the devices can measure or have some indication of how they are orientated or changes in their orientation. So things like magnetometers, where you're looking at the magnetic field, you can use that to work out, is the device north-facing or south-facing or whatever. So it's quite a rich range of different interfaces. If we're thinking about these interfaces, and some of these, if you are planning to use them within your game, there's a few things you need to be careful about. For quite a few of the sensors, they are fundamentally three-dimensional measurements. So things like acceleration or gravitational force or the gyroscope, they will give you a measurement that assumes it is a three-dimensional coordinate system. You've got an X, a Y, and a Z, a width, a height, and a depth. Reasonable, perfectly reasonable. If you do want to define or plot a measurement in 3 dimensions, you need to have a coordinate system for that. So this is what the measurements are relative to. If you say you need to have a coordinate system, then you need to define what those values mean within that coordinate system. And this is where convention comes into this. And there's lots of different ways you can define a 3-dimensional coordinate system. But for mobile devices, and actually for a wide range of other devices, they use a sort of a left-handed coordinate system where if you're holding the device in its default orientation, so holding the device the way it was designed to be held, then positive X points out to the right, negative X points to the left, positive Y points up the device, negative Y points down the device. For a left-handed system, then positive Z points out from the device towards you, and negative Z points away from the device, or into the device away from you. So that's just a way of defining what an X and a Y and a Z value actually mean relative to that center point on the device. There's an important aspect about this, that the coordinate system is defined relative to the default or the natural orientation of the device. Now, depending on the device, some devices will be designed to be held in portrait mode, others will be designed to be held in landscape mode. So, I mean, a mobile phone most often will be portrait. A tablet could well be designed to be held, as a large tablet, in landscape mode. Why does this matter? It matters because the coordinate system is fixed. It doesn't change. So if the phone is designed to be held in portrait mode, where positive X points to the right of the device, and you shift this around so you're holding it in landscape mode, now positive X is either going to point up the device or down the device, not to the left, not to the right. So the axes don't swap if you change the orientation. They are always defined relative to the default orientation. And that means that if you are, for example, using the accelerometer in the device, you need to be careful about asking, well, what is the default orientation of the device and how am I having to run my game? And if need be, swapping some of the axes around in terms of the measurements. There's a link provided on the screen here that you can sort of follow, and will give you a nice bit of detail about how you can take into account the orientation versus or against the default orientation of the device. Obviously, for mobile device with touch screen, we can touch it, and that's how we will provide probably most of our interface or input into our games. There's a range of established gestures, common gestures that are used in terms of a touch, double touch, a swipe, pinch, rotate, lots of different ways of interacting with it. We will want to define an interface for our game, probably using touch, and we need to be careful about this interface. Particularly, we've got a number of characteristics. We want to design it so that the user can easily provide input. They're going to be playing a game. They'll want to provide us their input into that game, and we want to make that as easy as we possibly can be for the user. So how we will get them to interact with the screen, we want it to be natural and appropriate to the game. We also want to make sure that, because it's a game, it's important that we are showing information to the user, and information that's likely to change as the game state of the world changes. That we also need to think about how we get the user to touch, and how will we ensure that the important information that we want to display to the user is still displayed, that their hands are not obscuring parts of the game within which important things are happening that we really want them to be able to see. So that puts a restriction into it. And the third one, also quite important, is that the user is probably going to be holding their device whilst they're playing the game. So we need to find a way to enable the user to hold the device in their hands, yet to be able to use their hands to provide input into the game, and to have arranged things in a way that we can still show the core information to the user in terms of what's happening within the game. And you've got a couple of sort of graphics here that show some of the common patterns, if you like, that have been established for gameplay mechanism. And you can see the one over on the far right at the bottom, that we're assuming that the hands are holding it, the thumbs are providing the input, and we've designed the game so that the important bit happens in the center of the screen, which shouldn't be obscured then by the thumbs. Depending on the game you're doing, you'll want to follow through and develop something similar by way of your design. And also there's a little bit of fun here that, and we'll do this within the lecture, maybe have a prize for it. If you were to develop a game for a mobile device where the temperature was the primary form of input, not necessarily the exclusive only form, but it was the most important form of input, what type of game might that be? So if you want, you can ponder that, but we'll do it within the lecture. Now that we've had a look at, very briefly, at mobile devices and the types of input they have and how we would like to design it, let's have a look now under the surface about the types of code that we will write that will be able to manage the input that we get from the user. And here we want to differentiate between what is event-driven activities and polling-based activities. So for event-driven, I'm assuming everybody's familiar with this, that we will have some event that can happen. It could be a touch event in a screen, it could be a change in an accelerometer or whatever. An event handler model of the world assumes that when an event happens, you have registered a handler with that particular event. So it's notified that this event has occurred. It notionally sort of takes the event in, it processes it, consumes the event, and that's the way that it happens. You've got a callback mechanism so that it's provided with the event and then takes whatever action it needs to take. It works fine. It's particularly suited to an awful lot of input where you have discrete events that are occurring within or through your application. For games, and this is what most games use, they use the notion of polling, and polling is a little bit different. The way polling works is that at regular intervals, and the period or the frequency of it can change. Within a game it's quite regular. We're doing this maybe 30, 40, 50 times a second. We check to see, well, what is the current state of our input? What's the value of this? Do we have any touch events? Where are those touch events? And we're looking for changes in the input from one pole to the next pole. And depending upon those changes, we will then take some appropriate action. So we'll have a look at input polling. In terms of advantages and disadvantages of this, input polling gives us a low level of control. We're doing this 40, 50 times a second. it fits in well with the update loop within the game, that because we are frequently updating the world, and because the user's input is a key component to that, then we frequently want to be checking to see, do we have a change in input? So that maps on well to a polling mechanism. In terms of the main disadvantage is that because we are looking at a snapshot of an instance in time, and because we have to basically work out what happens from one frame to the next, events that happen over a period of time. So there, for example, we might be drawing a gesture on the screen, and it may take the user half a second to draw the gesture, and that could relate to, say, 25 updates. We have to, as part of our coding, detect that gesture. We have to provide not only a process that works out, well, what's the difference from one frame to the next, but also asks, okay, over time the user's been doing this, so what is the significance of that period of change over time? So it's a little bit more work is involved by way of the detection of complex gestures. I mean, event-driven is not necessarily better for this, because if you have a complex gesture that, say, fits or falls outside the normal, say, pinch and drag and control ones, then you're going to have this type of mechanism for detecting it anyway. Here we have an example at the bottom. So we have a number of button pictures, and we're assuming here we're sampling at, say, 15 milliseconds across. And you can see that in terms of doing this here, for our first sample at 15 milliseconds in, the button was up. 30 milliseconds in, the button was down. Then it was, sorry, up again. Then it was down 45 milliseconds in, and for the next 4 times that we checked, the button was down. And then finally, 105 milliseconds into it, the button goes up. Small thing to notice there. So the button was down for a total of 60 milliseconds, 4 updates. If a player actually touches the screen or touches a button, they're extremely unlikely to be able to do it within 60 milliseconds. So in a game that's running, say, 50, 60 updates per second, a basic interface, even if the user tries to do it as quickly as possible, there will be multiple frames where that event will occur over. By looking then at the differences between the ups and the downs, we can see that the 3rd time we checked it, it becomes down, but in the previous frame it was up. So an up moving to a down, that effectively is a pressed event, that button, or for example the screen, has had a pressed event occurred on it. And then, was it 7 frames in, when it was down on the 6th frame, moving to up on the 7th frame, we detect that change and we say, oh, okay, this is a released. We've pressed the key and we have released the key. And if you press and release, it's also the same as having a typed event as well. So the work, we would have to do the work then in terms of working out what has changed. A couple of introductory pitfalls. These are things that well, hopefully you'll not end up doing, but we flagged them up now because it's some of the things that it is easy to fall into this little trap. If you have a look at the piece of code we have over on the left-hand side, we've got an update method. We're checking to see if the launch key has been pressed. So, for example, the player has touched a bit of the key or a bit of the screen that indicates you should launch a projectile. So if the player has pressed that, then we should indeed launch the projectile. On first glance, it looks perfectly sensible. If the launch key is pressed, then launch the projectile. However, you've got to think about this in terms of if we're calling this piece of code 60 times a second, for example, can the user only click it once within 60 seconds? No. If they're very quick, they might get away with 6 or 7 updates where that will be pressed in. And the thing that we do want to avoid is that we don't want to necessarily trigger 6 projectiles being launched. So you want to ask, okay, yes, the input is done, but is this a type of activity that I want to restrict to a certain number of times per second? Other related example to that would be, for example, an animation. That if the user presses, say, in this case it's a kick animation, you wouldn't want to constantly re-trigger the kick animation, say, 7 times before the key is released. Rather, you want to trigger it once and wait until the animation has finished before then allowing the user to provide another input, which would sort of change the state of the player. So the general form is that if the input event is detected, then check what conditions must be true before you actually want to execute that event. So in terms of the projectiles, it may be, was the last projectile shot more than half a second ago? In terms of the animation, it may be, is the player currently in an idle animation or a run animation, something you're willing to transition from. Other bit of advice is in terms of decoupling the input. And this opens up the opportunities by way of having different types of input that can trigger the same event, or having a game where you enable the user to configure whatever controls they want to use. I have to admit, for touch-based environments, there's maybe less configuration. You arguably could change the region on the screen, but in essence, it generally applies more where you have a controller with different sort of buttons or switches on it, where you let the player control which actions they map onto. The little fragment of code up on the top right is one where these two things are coupled together. So we're considering our input. If the A button is pressed, then we do whatever action we want to do, and with our prerequisites applied to it. So the two things are coupled, coupled together, that the action is coupled to the A button being pressed. The example down in the bottom is where we have it decoupled, where we are basically checking for input first of all. In this case, it's the A button or the J key. So if either of these things are true, we set a flag that says that yes, we want to, in this case, jump. And then later on, we consider, okay, has the user indicated that they want to jump? Do that through a flag, then we should take that particular action. So the two things are decoupled. We could have more than one input that would map onto that particular action, or we could let the user change that action. Generally, decoupling is a good thing to do within our programs. It helps promote extensibility within them. So a couple of key takeaways, fairly straightforward stuff. Tablets, smartphones, they support and increasingly support a very wide range of different types of input. I'm imagining for most of the games we're going to develop, it's simply going to be touch-based input, but it's not to say there aren't other opportunities. And we will, for most of the games, be using input polling, where as part of every update you will be wanting to ascertain, well, what has changed based on the input state from the last time that we checked, and based on that change then to trigger some appropriate action from it.